All right, here's just one more quick example of how to come up with a Karnaugh map and some statements from a binary table. This here is our binary table. That just counts up in binary, giving all possible combinations of true and false, or 0 and 1, for the inputs A, B, C, D, E. And there's only one output column. So often this final column here is called the output column. It's just the thing that we're trying to map, given all the combinations. So how we do that is, first of all, draw a Karnaugh map. That's a 4x4 grid. There are a few different ways of notating this, as you've seen, but the way that this course uses is to have A 0, 0, 1, 1, B 0, 1, 1, 0, C 0, 0, 1, 1, and D 0, 1, 1, 0. When you're drawing it yourself, it's important to note that that's not the only combination of things that work. You can have A and B and C and D anywhere, and that the zeros and ones don't matter too much either. If A was 0, 1, 1, 0 and B was 0, 0, 1, 1, that would still work just fine, as long as the things that are on opposite sides are skewed slightly, are alternating with what's zeros and what's ones. All right, so how I'm going to do this, looking at this table of this column here, this E column, I'm going to basically be going down that column. Now, I could note how many ones there are. In this case, there's 1, 2, 3, 4, 5, 6, 7, 8. So one possible way of doing this task is to go through every single row and of this, working out whether it's a 0 or a 1, and putting a 1 or a 0 in the appropriate place. But it saves time because we don't actually have to do all 16 of them. We can really just do the ones, and then we know everything else is a 0. Or if we've got a table that has way more ones than zeros, if we were doing something like 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 0, 1, 1, 1, it would be faster to just work out where the zeros are. So it doesn't really matter which way we do it. In this case, there's fewer ones than there are zeros. No, there's not. There's fewer zeros than there are ones, but that doesn't matter. I'm going to do the ones anyway. So in this case, I'm looking at this one and working out where that one fits on this Karnaugh map. In this case, my coordinates are essentially A is 0, B is 0, C is 0, D is 0. So I know that A is 0 tells me that it's in those 8 there. B is 0 eliminates it. Out of those 8, only those 4 have B as 0. C is 0. Out of those 4, only those 2 have C as 0. And D is 0. So out of those 2, that's the only one that has all those 4 coordinates as 0. So I'm going to undo all those. I know that I've isolated it down to that square, so that one, I put a 1 in. Let's go to the next one. That's this one here. And I can see here that this is A is 0, B is 1, C is 0, D is 0. So A is 0 means there, B is 1 means we're in those 4, C is 0 and D is 0 means that we're there. So I'm going to put a 1 in that spot there. Usually you don't draw circles over everything. That's just my way of showing you where my thinking is. Now our next one here, we know that A is 1 and everything else is 0. So A is 1 goes there, everything else is 0. Well, that's where B is 0. That's where C is 0. That's where D is 0. So I know that I'm in that square there. And then here, A is 1 and D is 1. So we're right next to those ones that I just had. But D is 1. So we're going to be in that square there. Here, next one is this one. A is 1. C is 1. The other 2 are 0. So A is 1. Let me erase just my red line there so that I don't get confused later on. All right, so A is 1, tells me I'm there. C is 1, tells me I'm there. B is 0 and D is 0, tells me that I am there. My next one is there. A is 1, B is 0, C is 1, D is 1. So that tells me that I'm in that square there. So the more you do this, the faster you get at it. Next one we're looking at is this one here, which is where A is 1, B is 1, and the other 2 is 0. That's going to be that square there. And finally, this one here, A is 1, B is 1, C is 1, and D is 0. So A is 1, there B is 1, there C is 1, there D is 0. The only place those all overlap is there. So I end up with this as my Karnaugh map for this input-output table. How do we take that into a statement? Well, let's remember we're doing our circling of groups. What I'm going to try and do first is identify groups of 8 as a rectangle. There aren't any. Identify groups of 4 as a rectangle. Well, there's that group there and that group there. And what I need to do finally is also that one there seems out by itself. However, let's not forget that we can overlap. So I could overlap it like that, but also let's not forget that the bigger the overlap, the better, or the bigger the group, the better. And so the actual best overlap to use here is that one. That's going to give me an output. And so now I've got 3 different circles, each of which covers the entire set of ones that I need. And so in this case, I can now write that. This one here is the case where C is 0 and D is 0. So I've got not C and not D, or, and this one here is the case where A is 1 and B is 0. So A and not B, because A is 1 and B is 0. Or, and I've got to do this one here, which is the case where, what do we know about these two things? What do they have in common? Well, what they have in common is that D is 0 and A is 1. So that's A and not D. And I finished. While I'm recording this video, let me quickly explain to you exercise 41, which is asking you to do that several times. It's just in a different, expressed in a different, slightly strange situation. But how we do this one here is that essentially in our table, in every table where we do these problems, these columns A, B, C, D are always the same. They're always just counting upwards in binary. And so here we've got our inputs, which are the same. And then you can imagine one table that looks like this, that has this as our column E. So imagine that as a table, and then go through the entire process that I did to come up with a statement for this column V as an output. That's one question. And then do the same, but without column V in there. So let's forget about that column there. And now let's imagine a table that has those 4 inputs with that column W as the 5th column. Go through the same whole process. You will come up with a statement for W, etc., etc. So you're just going to go through this output table, treating it one column at a time, and for each column you can do a Karnaugh map and a statement. All right, that's what we're doing today. Good luck.